Scala is one of the most advanced computer languages of today. Its feature set can be mind-blowing to the average working-class programmer. It is heavily used in big data and data science projects and applications. It runs much of the good part of the AI surrounding us. In this preface or even introductory lecture, we are going to scan this language coming from the mindset of, as we said, the working class Java, what was ex-OOP programmer. So you were an OOP programmer in Java, you started Scala, you know some of its concepts, but you want to go further to the extreme of it. What Scala means to us and why we should actually maybe even hate it, and also why we should love it, and in general what we should do about Scala and how can we learn it properly. So without further ado, let's begin. So what are we going to cover in this lecture? First, we are going to ask, is Scala scaring you? Okay, because if it is, there are reasons for that, and we will scan some of the reasons. And as part of the solution to how to properly learn Scala, we would mention what Haskell and math means in the context of Scala. Also, we will scan some of the terminology. We won't explain it, but we will simply go through some words, what is called the terminology neutron bomb of Scala. Why neutron bomb? Because it's rather quiet, but it has a large effect. We would also check if Scala code is readable, at least at first sight. Now again, this is a rather small lecture. We are not going to get deep, but in the next lectures we are going to get deep inside these subjects. Also, we will ask why do we want functional programming, and we are not asking it as people who are already convinced to use functional programming. We will really try to understand if we want functional programming or not. We also want to understand the difference between imperative and declarative, and we will do it through a very simple example. And last, we will just say a few words about immutability, and with this we will finish this first episode, which you can also hear as a podcast of functional programming Scala concepts, which we hope that you will gain much in the future episodes. So let's continue to the first concept. Now, have you ever been to a Scala conference and told yourself, I have no idea what this guy is talking about? Because if you did have this moment or moments or many moments, then I also had them. And did you look nervously around as me and saw people that are smiling and are happy with what the presenter is presenting and saying, yeah, this is obvious? Did that only get you even more nervous? Because it did get me more nervous. I asked myself, what is wrong with me? Why do I not get these concepts? But with that, I started a journey into understanding the advanced concept, and I will lay out them in the next lectures so you won't do the same mistakes, and I will help you get these concepts hopefully clearly. So, if you did have these moments or are still having these moments in some Scala conferences, then this post is for you. Otherwise, you already understand Scala. If you have been to Scala conferences and everything was clear, you understand it, please close the video. Okay, this is not for you. Okay, so this post is optimistic. It's optimistic because although I'm going to say that functional programming is not easy, then our target in this series of podcasts or lectures, however you prefer to listen to them, is to understand these concepts of Scala. So please bear with me, and but I want first to face the truth. And the truth is that functional programming in Scala is difficult. It is difficult if you are, especially if you are a programmer coming from a Java background. Then if you came from other functional languages, then it might be easier for you. If you have a heavy math background, then Scala can be very easy for you. So if you have some Haskell background, then Scala, hell yeah, it's very easy. If you have some heavy math background, then yeah, hell yeah, Scala is going to be very easy for you, and you're going to like it very much. And with that, I want first to cover what's the first barrier into getting into Scala. Well, the first one is that there are many new concepts. Now, let's just mention the names of these concepts and terminology because we will cover them in the next lecture. So I just want to tell you them because for a newcomer, it can be scary. Now, the terminology is Mixins, Implicits, ADT, aka abstract data structures, typeclasses, lazy evaluation, duck typing, memoizations, lens, type linearization, stackable traits, monads, semigroups, functor, typeclasses, higher order functions, higher order types, partially applied functions, and partial functions, which is a different thing than partially applied functions. So we have all this mind-blowing terminology, and it's not by coincidence, because Scala is a functional language, and if you really want to understand functional language, then you will need to understand this concept. This does not mean that the explanation of these concepts must be complex. They are a little bit complex, but this does not imply that we should explain them in a complex way. So let's begin with some criticism of Scala. Now, if you show, I claim that if you show a piece of code to any developer with almost any background, who at least have a few years maybe of experience, then any code should be readable. And if not, then I claim that this is not okay. Now, is the following code readable to a programmer which does not know Scala or is mainly using object-oriented language? Now, it's really not. Now, you can say, yeah, but also in Lisp, it would not be really clear. So, I'm not sure about it. I looked at Lisp code and it was clearer than this code. Now, this is not a complex example. I could show more complex example. I picked up something that I could present to a beginner programmer or an advanced programmer with some experience in OP, but this is not clear. And why isn't? Let's talk about it. Why isn't this code clear? Well, it has some concepts which are not known to the usual OP programmer. For example, free. Yes, you see here the word free. What is free? I mean, yeah. And the word, okay, pure, I can guess it's a pure function. So it's accepting some A, it's returning a free of a requestable. What is requestable? It's not that clear. And you have, and above that you have lift, FC, okay, which accepts a pure, and this pure, lift, free is not making things easier, and all these types are not making these things easier. So that's one of the strengths of Scala is the type system, but in combination with all these new concepts, it's not that clear. So a language that has less boilerplate and can present the same concepts in a more fluent way, like Haskell, is much more beneficial in order to learn these concepts and not to mess with two problems at once, both the concepts and the terminology and the complex and the verbose, rather verbose type system. Okay, although we have type inference and it's good type system, but I just want to present here that I'm sorry, but this code is not that readable. Okay, but we have to face it. So how can we approach learning Scala? Well, I thought about it while learning it. Well, I started learning Haskell, and I have to say that this made things easier for learning Scala. Now, this should not imply that a busy programmer should first learn Haskell. This is not a good way to learn Scala. It's a good way if you have the time, but if you're busy and you don't have the time to learn Haskell, which I think you should learn by other means because it's a good programming language, but you should not learn it. It's not ethical to tell you that you need to learn another language in order to learn Scala, right? So we'll need to make some better progress on it and not have Haskell as a precondition. Now, having said all the above, we have to realize, and I have to tell you that I cannot stress enough how much functional programming is important. And it's not important only because of the functional programming concept. It's important in higher order concept. There is a higher order concept that your code should be clean, right? This implies both to object-oriented programming and also to functional programming. I don't care if you program in assembly, which is imperative, or with 1 zeros, or with Pascal, or with Scala, or with Haskell. Your code should be clean. And this is why functional programming is important, because it will help you create cleaner code. It will help you create a core which you can test. Okay, so not only that, you will gain some other aspects which are everybody are talking about, but I'll less consider it. I really stress that the cleaner code, testable code, is the most important thing. You also get the benefit, which others stress, but I don't, of concurrency, and you can work with the big data, parallel computing. So functional programming is like a Swiss knife for a programmer who wants to become a better programmer. Simply do functional programming. You will write clean, pure code. You will have a separation of the core, which is of pure functions, and the I/O surrounding this core. It's a dream. It's actually a dream come to life of a clean code lover. And this is the main reason we're going to make this effort for learning functional programming. Now, the problem with that is all this good stuff which comes with functional programming is what's making all the noise. Because remember, our world is not pure, right? We have all this evil in this world, and we covered it in the Schopenhauer lecture. The world is cruel. The world is cruel. We mean we need to do I/O. We need to do mutation. We need to write to disk. We have the external world, which is not idempotent, right? So because we have this division between the world, the real world, and functional programming, this is what's making much of the noise, and this is what's making functional programming less readable and clear. It's the solution of the problem to overcome the limitations of functional programming into the real world, which is making things a little bit more difficult. But it's not only this. When we work with functional programming, we work with some higher order and with the pure functions, and in order to work with these concepts, we have to make other things more complex, but I claim that it's worth it. It's worth learning it, both to extend your brain capabilities, and it's worth it because your code would be more bullet proof. But so we discussed the benefits of functional programming. Now, are there benefits to imperative programming? So there are, yes. Imperative programming, as its name is very imperative, which means you can look at the code and you will see exactly what's the steps it's executing. Now Scala advanced programmers will kill me now because I'm saying imperative programming is good, but I have to say that one of the most important things in code is to understand it. And if you understand it, then this is good. Now, so imperative programming can be good, and advanced Scala programmers, please don't assassinate me on this. So if you have some basic sanity of clean code and practices, you can write a well-organized and clean code also with imperative programming. Now, what you need to focus on when you write imperative programming will be small functions, mutations when needed, not always, because many times you can avoid mutation. It's not turning everything into functional. You can still use loops instead of flat map, the twin brothers. And you know what? You can use the Java util concurrency building blocks, non-blocking I/O, and also you can use multiple threads. And in this way you will write excellent applications which are both high performing utilization. And I know this from first hand because I have some experience, and I did write some high-scale demand applications with imperative programming before I knew all the declarative stuff. So let's continue to discuss about imperative versus declarative code writing. So the below code is an example of an imperative code. Now this example is taken from a great post by Jenkov, which has many other great posts which I recommend you to read. Now he has an article named The Illusion of Declarative Code. In his post he presents an example of an imperative code. Now what this imperative code says, it says a function capital with interest, and the parameters are capital, interest, and periods, and then he has var. Note it's a var, not a var, result equal capital, and then he has a for loop from I equals 0 and increases it until it reaches limit periods, and then he assigns to the result times 1 plus the interest, and then he returns the result. So in general he had a function. The function takes a few parameters, it creates a new variable of result, it loops with a for loop and computes something by mutating the result. So it's both mutating and it's also having a for loop. And it's very this is the canonical example of imperative code. Now, although this is not declarative and this is not what we want to do with Scala, this is clear. We really see what's going on here, although it's a little bit error prone because you need to control the loop, you need to pay attention to the indexes, but I think it's clear code. Yeah, it's a small function. It does rather one thing, and it's a good function. Now, but the main thing is that this function is imperative. Now, Jenkov asks in his article, what is the declarative function of that code? Well, the declarative version of this code is simply calling this function. If you had the above code inside somewhere else, and you didn't have the function name, it would be imperative. But once you give this piece of code a name, in our case the name is capital with interest, then it's not, then the content here is, we simply call a function, we simply say what our intention is, and our intention is to calculate the capital with interest. We are not interested in the boilerplate, in the internals of the function. Now, this function has internally only the imperative code, but externally it is a declarative function, which is good. So when you call map, when you call flat map, when you call other declarative so-called functions, then these functions internally does the traverse of the collections for you, which makes them declarative for you because you just call the function, you just call the ready-made map and flat map. Okay, so in Scala, the canonical example, I think, in my opinion, of declarative code is simply that you have some list of numbers, 1, 2, 3. Let's say you have a list of 1, 2, 3, and you call them list of numbers. And this is val, not var, which means it's an immutable, it's a constant almost. Okay, so you do list of numbers dot map -2 for each println. So notice here we didn't do any loop. We just mapped over the list of numbers, which means we called By mapping, we mean we call a function named map, and we let the function map do whatever it needs to do in order to traverse the number. So I could call it list of numbers dot traverse. Now map does a few more things, which is the boxing, but it's not relevant at this stage because we are going to discuss it further on. So we didn't tell imperatively what the exact steps. We just told the Scala map over this list, remove 2 from each item, and then print the items. Another important base concept is functional programming in Scala and in general, and immutability. Now, because in functional programming we would rather have pure functions, then there is a consequence to that, and the consequence is that we use immutability more and more, as much as we can, and this is in favor of mutable data structure. In the great book Scala Design Patterns, the author says, quote, that immutability is an important principle in Scala and it should be preferred. The builder design pattern with case classes uses immutable fields, and this is considered a good practice, which means that we prefer immutability because when you are immutable, you are not changing stuff, and when you are not changing stuff, then your functions are pure, and this is the essence of functional programming, to have your functions pure, which means they have no side effect, and if there is no side effect, then you have less mutation. I'm not saying not mutation at all, but you have less mutation. You don't want to mutate things, you want to reinstantiate a new thing instead of another thing. So yes, in this case our case classes, which inherit from still traits, are not only a great way to model the data in the case of case classes, they are also immutable data structures by default, and I'm taking into granted in these lectures that you already know the base syntax, which is case classes and stuff like this. So to summarize this first episode, then we have just touched the surface. We just touched the motivation to learn functional programming, the benefits of both imperative and declarative programming, and the benefits of a little bit about immutability. We bombed you a little bit with the terminology, and in the next episodes we are going to discuss more the actual terms. And I really hope to get your comments in order to get feedback, because I want to know what you think about this video, if it's unclear, and this would help me create better videos for you. So thank you, and see you in the next lecture.